Hey everybody, welcome to another Colin support video. This time it is on writing linear functions word problems. Okay, let's go. So it says, Nolly is escaping from the dragon's lair. She is running toward the entrance of the lair at a speed of 9.2 meters per second. The entrance is 180 meters away. So remember, the key here is to identify what the growth rate is, that's the slope, and then where it starts, and that is the y-intercept. So it's always going to be in the form y equals mx plus b. Whether they change the variables for x and y doesn't make a difference. This is the structure of it. Okay, the growth rate is going to be the m, and basically where it starts is going to be the b. So in this case, her growth rate is that she's going at 9.2 meters per second. So she's going at 9.2 meters per second. So that means that you're multiplying every x seconds by 9.2 meters. And she's running towards the entrance. So basically, she's going to be reducing the distance to the entrance. Okay. And then, or you could think of it the other way around. I suppose you could make the distance away minus 180 meters, but we're going to make the 180 positive. So the entrance is 180 meters away, so that's plus 180. And so basically, this will tell you how many seconds it will take her to get to 0. And if she gets to 0, that would be at the exit, basically. So it says the distance d between Nala and the entrance of the layer is a function of t, the time in seconds since Nala began running. So they're saying that d is equal to negative 9.2 t plus 180, where d is basically the distance between Nala and the entrance. So when d is 0, she's at the entrance. Okay. So it says write the function's formula. So, okay, let's write it in. Minus 9.2 t, and then plus 180. And the reason that we did the minus 9.2 instead of the positive 9.2 is because her distance from the entrance isn't increasing, it's decreasing, right? They're getting closer and closer to the entrance. And so that's that. All right, let's do the next one. So this one says, let me pause this for a second. So Bob the Wizard makes magical brooms. He charges 125 gold pieces for each magical broom he makes for his customers. He also charges a one-time fee of 50 gold pieces for his initial consultation. The total number of G gold pieces Bob charges is a function of X, the number of magical brooms that he makes. So once again, it's just going to be y equals mx plus b, where m is how it grows and b is where it starts. It's basically going to start with this fee of $50. That's an initial fee. It's not going to change. So no matter how many broomsticks you want made, you're going to pay that fee for the consultation. And so that's a constant. And then the slope is going to be 125 gold pieces for each magical broom. So 125 for every broom. And so that's what we're talking about, right? So it's going to be y equals 125x plus 50, where g is the y, basically, right? The amount of gold and all. And then x is the number of magical brooms he wants. So g equals 125x plus 50 is your final equation. 125 times x, right? 125 gold pieces for every wand, every broom, I should say. And then it starts at a $50 consultation fee, or 50 gold piece consultation fee. So that's your equation. This one says the temperature of a chemical solution is originally 21 degrees Celsius. A chemist heats the solution at a constant rate, and the temperature of the solution is 75 degrees Celsius after 12 minutes of heating. The temperature T of the solution is C degrees Celsius as a function of X, the heating time in minutes. Write the formula. Okay, so what do we know? We know that the temperature of the chemical solution is originally 21. So we know that in y equals mx plus b, the y-intercept is 21. So we know this is plus 21. Okay, we know there's a constant rate, so we know there's some m that we're going to have times x is going to equal y, right? Plus this 21 constant. It says here that the solution at a constant rate, the temperature of the solution is 75 degrees after 12 minutes. So what do we know? We know that the temperature is 75 degrees when the minutes is 12. So that means that x is 12. So we know all these elements, we just don't know what the constant rate is. So just solve for m. So we're going to minus 21 from both sides. and you're going to get, let's see, 74 minus 20, so it's going to be 54. So 54 is equal to 12m. Is that correct? 70 minus 20 is 50. 5 minus 1 is 4. Yeah, 54. Then you're going to undo times by 12, so you're going to divide by 12 both sides, and you're going to get that m is equal to 54 over 12. 12 goes into 54 4 times, which is 48, with 4 left over. So 4 and 4/12, or 4 and 1/3, which is 4.3 repeating. So we're going to say 4 and 1/3 equals m. So that's kind of the idea here. So we know that the multiplier is 4 and 1/3 meter. I guess it's not meters. It's going to be is it degrees Celsius per minute. Okay, so the rate is 4 and 1/3 degrees Celsius per minute. And so our equation would be the multiplier 4 and 1/3. So that's the same as 12 plus 1 is 13. So we can just say 13 thirds. That's the same as 4 and 1/3 times x, and then plus 21. And if we write that out, let's see if it all makes sense of the story. So the temperature of the chemical solution is originally 21. Let's say 21. The chemist heats the solution at a constant rate of 13 thirds, and the temperature of the solution is 75 degrees Celsius after 12 minutes of heating. So just let's check it with a calculator before we hit enter. So after 12 minutes of heating, 13 times 12, 156 divided by 3, plus 21 should equal 73. Oh, 73. I made a mistake somewhere. Let's try that again. So 13 times 12 is 156 divided by 3 is 52, and then 52 plus 21 is 73. We want it to be 75, so I must have made a boo-boo. So what did I do wrong here on the boo-boo? 54 divided by 12. What is 54 divided by 12? 54 divided by 12. Oh, it's 4.5. Silly me. The good thing I checked my answer, right? So anyways, you can go in here and check your answer, and we can see that 54 divided by 12, 12 times 4 is 48, but 48 to 54 is 6. Oh, so it's not 4/12, it's 6/12. Silly me. It's going to be 6/12. All right, so that's going to be 1/2. Good thing I checked, huh? All right, so always check your work. And then, anyways, so it's going to be not 13 thirds, it's going to be 4 and 1/2, which is basically 4.5. So we can just change this to 4.5. So 4.5. Now it'll work. All right, awesome. Yeah, I always, whenever I get like fractions or decimals, I always plug it in and check to make sure it all works the way it's supposed to. All right, when Joseph first starts working at a grocery store, his hourly rate is $10 for each year he works at the grocery store. 1 second. When Joseph first starts working at a grocery store, his hourly rate is $10. For each year he works at the grocery store, his hourly rate increases by 50 cents. Okay, Joseph's hourly rate R in dollars is a function of T, the number of years he works at the grocery store. Okay, so when we talk about this equation, it's going to be that same idea of y equals mx plus b, where m is your growth rate and b is your starting value. So it says that when he starts working at the grocery store, his hourly rate is $10. So that means that his base starting value is $10, right? And for each year he works at the grocery store, his hourly increases by 50 cents. So every input of time, every 1x, it's going to go up by 50 cents for y. So that means that your multiplier, your slope, is 0.5. So we know that's going to be y equals 0.5x plus 10 to get his salary after x number of years, where x is years and y is the salary. Okay. And so then they want to change the letters a little bit. So they say Joseph's hourly rate R, so we want y to be R, is equal to a function of time. So they want the x to be t. So now you've got your equation, right? So R is equal to 0.5t plus 10. Let me write that in, 0.5t plus 10. And that's going to be that. All right, so that's how you do those types of problems. Hopefully that's helpful to you guys. Let me just end that video.